How's it going, everybody? So a couple of weeks ago, you guys watched me build this disc sander, and the only thing I really like about this disc sander is it's really good for but it's really not good for much else because it's way overpowered. And so instead I built, this new disc sander, and this solves every single problem that I ran into with this first version. So today's video is about building this.
Daddy, did you just bring me out here to jump scare me?
No. Maybe. So the first consideration you're going to want to make when you're making a disc sander is trying to figure out what kind of motor you want. Ideally, you would want something that spins at about 1700 RPM and is about 1 horsepower. Unfortunately, this one is about double the power at 2 horsepower and about 3 times the speed at about 1500 RPMs, which actually makes this thing just a little bit dangerous to run. So this thing is a little bit less than ideal. This actually came from an old circular saw, by the way. The second thing that comes up a lot when people are making disc sanders are these old drills, which is really good for something like my homemade spindle sander, but it's really not great for something like a disc sander. Because when you have a disc all the way out on the edge, you have a lot of leverage here on the side, and when you want to sand, you're pushing usually on this outer edge, and you're going to have a lot of stability on that outer edge, and something like a drill really isn't designed for all of that sideways pressure. Now what I ended up going with my new disc sander is this 3/4 horsepower 3500 RPM motor, which is still a little bit faster than you want it to be, but it's also slightly underpowered for what you would want it to be. So it kind of evens out. So if you can find one that runs at a 1700 RPMs and gives you about a 1 to 1 1/4 horsepower, that would actually be ideal. But for me, this induction motor is going to work pretty well. Okay, so I brought out all of the tabletop pieces that I have, and what I'm looking for is something that is about 12 inches wide, and it looks like if I put these on here, okay, so this is 12.5 inches wide, so that's perfect. I'm gonna be able to get my main disc out of that. Now you don't need hardwood for the disc. You could use something as simple as like a 2x4 material, some sort of pine would be just fine. I'm gonna make mine a little bit heavier, mostly so that I get a little bit of extra momentum. So what I'm gonna wanna do is cut the main disc out of this, and I'm gonna wanna cut a smaller disc as well to act as a backer, and I'll explain why I'm doing that here in just a little bit. So I need to joint these together and glue them up for the next step. Now that I have that disc gluing up, now I can start on the box that holds the motor. Okay, I'm not going to tell you how to use your tools. Basically all we're doing here is we're going to be building a box, and the easiest way, in my opinion, to do this is just glue and brads. You just make a mark 3/4 in from the top and 3/4 down. And now standing this box up on its side here, that's our first hole we're going to drill. And the other one, I want to make sure that the knobs I'm using are these 5/16 inch bolts with a star knob on them. And I want enough room to get my hand around it. I'm just going to go ahead and draw it right in half, so that means my mark can be transferred there. And that's 3/4. So now we can go drill these holes, and we got to make sure the other side is a mirror image to this. So let's go put those together. Now the bolts I'm using, like I said, are 5/16, so I'm going to chuck in a 5/16 inch brad point. All right, we want to make sure that these are exactly the same, so I'm just going to drill them at the same time. The main reason I'm adding a second piece to the outside is because this is the piece that's going to be holding the table in the future, and I want to make sure it has a ton of rigidity. Okay, so now what we need is a square piece that is the same height as this. So we need a board that is 7.5 tall by 7.5 wide. Alright, now what I need to do is transfer all of my holes. There's no hole on the inside of this piece yet, and I also need to figure out where the holes go on my trunnions. And so the way we do that is this one is going to get a backer. Alright, now those are drilled all the way through. Now what I need to do is find the holes for the trunnions. So the way this works is this is the pivot point here. So we're going to have to figure out this position all the way to this position. So the way we find that angle is I'm going to go ahead and just put a pencil in here. And I'm going to go to 90. So now we're going to drill through the trunnion on this side. And then we're going to find 90. And we're going to drill that again. Ow. And you can see that I have my arc and I have my two end points. And so now what I'm going to do is I'm going to take my compass and we're going to go right to each of the extremes here. All right, and then now all I have to do is remove all of this material any way I feel like, and I'm going to be using the scroll saw for that. There we go, and then that is the trunnion. Now what we can do if we want to is trim an arc on here. You know what? I think this would be more aesthetically pleasing if I cut this in a little further. Hold on. Yeah, all right. This next step is completely unnecessary. I just wanted to run the disc sander again. I love how absurd this thing. I don't want to get rid of it. I like it. The top section up here is going to have one bolt going this way with a washer and a lock nut on it. And the bottom one is going to come out here, this direction. That's also going to get a washer, but that's going to get a star knob. However, all of these bolts are too long, so when this goes through, I'm going to put a washer on, and then I'm going to put a normal nut on, then I can cut it to length and pull the nut off, and then I'm going to do the same thing with the bottom, and then I can go ahead and just assemble everything. Okay, so this comes up just like that. And our table is going to want to be in the line from the center of this bolt. That's going to also be the face of our disc. So if this is going to lower, you can see this corner is going to be in our way. So the way we solve that, I'm just going to go ahead and mark everywhere that's exposed, like that. And we're going to do that on both sides, and then we're just going to remove that, probably with a sander. I changed my mind. I'm using the scroll saw. You're not going to be able to see a dang thing. This has been about 2 hours since I started this glue up. It's not ready to be spun up yet, but it's good enough to where I can start cutting out my circles. You really do not want to spin this on your motor until it's fully sealed up. There we go. Now you can use any saw that you want to cut this out. You can use a jigsaw or whatever. I'm probably still going to use my scroll saw because I like using the scroll saw. You just want to make sure to cut well outside of your line, and you're going to lathe down to this line later. So this shaft here comes out to about 0.65, which is the same as a 5/8. And so I drilled this hole using a Forstner bit, but I don't like how much wobble is on there. So then I drilled this hole here. It's much tighter, and that was with this spade bit. But there's still a tiny bit of wobble in here, so I'm gonna go ahead and shave the sides down just ever so gently. All right, that is much better. Zero wobble. This circle here is small enough I can drill it on the drill press. Now, unfortunately, my drill press, no matter how I place this, is not going to be able to drill this hole. So I'm just going to drill this very carefully by eye. There we go. That's as accurate as I can get that. You know what I really need to make is one of those mobile drill presses, right? I could make one of those. Time to figure out where this motor is going to go. So I'm going to have a piece of plywood here later, so I want to leave room for that, and I'm going to use this one here as a spacer, and then this can just sit right over the top there, and that will let me square up the front of the motor. I wasn't sure how I was going to attach this motor, so for right now, I'm just putting screws into a scrap piece of plywood. The next thing that I need to do is I need to put some blocking in here so that I have something to screw the bottom onto. The next step was to put the bottom on the box, and I intentionally left it wide so that I could screw it down to a base in the future. Finding the screw holes can be a bit tricky. All I did was mark each of the screw positions on each of the edges, and then found the actual screw hole by drawing in from each of the edges using a square. Alright, so as I lathe this, I'm not going to be actually cutting it the way you would normally do this. I'm going to stay below it so that I can just skim it and try and get this thing as round as possible before I put the table on. It definitely got looser on the spindle. Okay. So basically what was happening here is the centrifugal force was so great on the disc because of how unbalanced it was and how fast I was spinning it while lathing it that it wallowed out the hole a little bit and it wasn't fitting snug anymore. So the way I fixed this was I put a little bit of wood glue inside the hole and then put it back on the spindle. Because this is just wood glue, it's not actually glued onto the spindle, so I can get this off in the future, but it's just filling up some of those gaps so that I can lathe the other side down, and then it will be perfectly balanced. Okay, this is the temporary piece of plywood you guys saw me use, and it was my intention to get another piece of 1/2-inch plywood to cover all of this up and make it look much cleaner. But it ended up being that I made these rails just a little bit too high. So instead what I did is I cut 3 of these 3/8-inch pieces of plywood that's going to go in here instead, and that's going to help me dial in the exact height that I need. Okay, before I put the motor on, I want to figure out how to install my switch. This is the switch that came with the motor. And I think what I want to do is install it somewhere in the middle. No. Left-handed. I want the switch to be left-handed because I'm going to be holding my piece with the right. So we're going to have a switch like that. We don't want the switch to be back and forth because that'll allow it to be bumped more easily. I'm going to push this up and down. And this thread here isn't long enough to go through both pieces of my plywood. So I'm going to have to countersink from the inside. I seem to be missing the footage where I drilled the holes for the bolts. It's really straightforward. It's basically the same process as I use for the screws by putting a spacer behind the disc and using that to determine where the holes should go. Because of the shape of this motor mount, it was a bit difficult to get the bolts in place with this heavy motor. I found it really helpful to put a block underneath the motor so that I could put the bolts in place, and then when I pull the block out, everything just falls right into place. seen screws?
Yeah.
Oh. I cut this washer to fit over here exactly so that there'd be a nice solid piece to attach to. All right, you ready? Oh, that's amazing. It works! Okay, so now I'm gonna start working on the front of the housing. This is gonna go directly behind the disc. Now, I'm not a big fan of doing CAD work, and so a lot of times I will make these templates off screen so I can really dial in exactly what I want. If you've never seen this stuff, this is hardboard that has just been painted on one side, and it's got a real nice finish on it, and it's very easy to draw on. So I love making templates out of this material. Unfortunately, I messed up this template a little bit. This side is not correct, so I'm just gonna go ahead and flip this because I know that side is correct. We're just gonna connect those. And that is going to be the front piece to my housing. What I'm working on now is the housing, and technically all of these next few steps can be skipped if you want the disc sander to just be finished. You can just throw a table on and you'd be done right now. But I wanted mine to be completely enclosed to manage all of the pinch points. And this is quite honestly one of my favorite parts about the build, because you can actually build the majority of the housing in place, making sure that you put screws where you want it to be temporarily affixed to later, and glue and brad nails anywhere you want it to be permanently affixed together, so that you can build the whole housing as one component, and it's completely detachable later if you want to get to the motor. And of course, none of this is actually necessary if you want to skip the housing. But I went for it anyway because I thought it would look a lot nicer if I finished it that way. Okay, so I have 3 different pieces here. These 2 on the end have flats on the end. These 2 here are the same size and they're double beveled. This large wide one spans the top and it has also got a double bevel on it. And then I also have these blocks. Let's see, they're gonna go like this. Nope, they're gonna go like that. And those are gonna be glued on so that I have something to adhere to at the top. So. These blocks I'm putting in right now are just temporary until I get the real blocks made and while the glue dries up. There we go. Now I need to connect this temporarily to this portion of the housing. We got enough. This is what I was talking about earlier by connecting the front of the housing to the back of the housing, effectively making it one piece. And here's the moment of truth to see if everything comes off in one piece. Perfect. I can't believe that worked. And then once I had the housing off in effectively one piece, I was able to screw it together using the blocks I installed earlier. So unfortunately I lost a little bit of footage here at the end, but mostly the only footage that I actually lost was the finishing process. All I really did was put a flooring finish on, and then I scraped it so it was nice and smooth. And then I put a couple pin nails in to hold the table in, and I glued that in place, and then it only took 4 screws to put the housing together, and the disc sander was finished. And I loved the way this thing turned out. Oh, it's so cool! This whole thing turned out surprisingly stable. There's only a little bit of vibration. And it's really powerful. It just eats it up. This thing still takes a long time to spin down. Hey, thank y'all for watching. I thoroughly enjoy building these redemption projects, you know, where you build the first version of a project, but then you learn so much from it that you can implement all those into the new project. You basically end up with hindsight on your side, and you actually can build something that you're truly proud of. I love projects like that. But let me know in the comments what you think. Are there any things that you would change on something like this? If any of you are planning on building something like a disc sander, there's a couple of things to consider to make it a lot easier on yourself. I decided that I wanted this moving tray on mine, but you don't really need that. Most people are just going to be sanding at 90 degrees anyway, so this could really just be changed into a normal box. And the same thing goes for this housing as well. This whole housing could be easily changed into something that's just square, and that would drastically simplify everything. Or you could go without the housing, and this project could be done in about an afternoon if you really wanted to simplify this. But let me know in the comments if there's anything you would change. Let me know if this is something you might be interested in building in the future. I'd love to hear your guys' ideas. Well, anyway, thank you all for watching. Catch y'all next time.
This is the end. See you in the end. See you in the end. Let's pick up. Let's pick up. Let's pick up. See